Hello ladies and gentlemen, this is the Productivity Improvement Study presentation from SOM. The coming presentation is going to cover 7 different aspects as follows: area of study, set condition, method of study, analysis of existing operation and problems, improvement proposals, and how they are going to be implemented, as well as finally the conclusion part. Now let's get started with the area of study. The construction process we observed and analyzed is the exterior wall assembling. All the concrete wall panels are precasted in the factory and transported to the construction site by trucks. Due to the limit of the site, wall panels are transported only one at a time. After trucks arriving at the site, laborers will climb on the truck to assemble temporary supports and hooks. Then the crane will operate to erect the panel and move it to its designated location, and the laborers will work to fix the panel to the ground. Further connections to stabilize the panels will be welded and bolted afterwards. To help you have a better understanding about the site, I'd like to make a general introduction about the ongoing project on the site. The project is a 14-floor luxury student apartment building of 218 residential units. Located on the cross of 4th Street and John Street, the project was developed by Opus Development Company and constructed by Opus Design Build Company. By the time we arrived at the site, the company was constructing the first 3 floors, and the steel frame systems were almost finished. Totally 5 workers, 1 crane and 1 lift were observed as working on the wall assembling cycles. Additionally, according to the observation, the site did exist some potential safety problems needed to be improved, but as they don't have real impacts on productivity, these problems won't be further discussed in our study. Now let's talk about the method of study we used during the analysis. Generally speaking, 3 different productivity analysis methods were included in the study. Crew balance chart, which is a vertical graphic technique used to record and analyze the behavior of each labor at each time during a construction cycle. Process charts, a chronologically arranged listing of the various steps in an operation. Flow diagrams, a line sketch showing the movement of workers or materials, usually combined with process charts. Based on the 3 methods mentioned, we started the study by analyzing the existing operation and problems. From the crew balance chart shown on the screen, we found out that some of the activities, their productivities are dominated by the crane and lift, but not the perform of workers. For example, panel erecting, locating, and hooks removing. As a result, some of these activities seem to be non-dividable, which means at a certain time, idling workers are inevitable. Similarly, some of the activities are mainly conducted and dominated by workers, which means during these activities, idling of crane and lift are inevitable, because there is only 1 wall panel available at a time on the construction site. But the good news is, we did find out some workers idling which can be avoided and improved. And based on all these 3 cognitions above, we will generate our improvement proposals. Now let's take a look at the proposal number 1. In our proposal number 1, there is no extra laborers or equipment are added to the current construction site. To reduce the idle time of laborers and equipment, we consider 3 different principles for the proposal number 1. First principle, the erecting time, hook removing time, and locating time are non-dividable in the construction site. Secondly, there is no idle time in between the activities in the critical path. And the last principle is, works that are dividable are assigned to more laborers to reduce the idle time. So generally speaking, our proposal number 1 are the proposal based on existing conditions and rules, but only trying to rearrange the resources. Now as you can see, The new crew balance chart generated by our proposal number 1 is shown on the screen. 3 main improvements are made by our proposal number 1. First of all, before adjusting, foreman and laborer 1 take 9 minutes to install the temporary support, and after adjusting, 2 more laborers were involved in this process. It takes foreman and laborer 1 4 minutes, and laborer 2, laborer 3 5 minutes to install the temporary support together. The second improvement, before adjusting, foreman and laborer 1 use 7 minutes, and at the same time, laborer 2 and laborer 3 will use 11 minutes to fix the panel to the ground. After adjusting, time were evenly distributed to everyone. And the last improvement, the typical cycle time is reduced from 38 minutes to 31 minutes, which reduced the idle time effectively. So as a result, the productivity of our proposal number 1 is 0.276 slab per man-hour, and the cost will be $319 per slab. Now let's come to our second proposal. Our proposal number 2 is kind of similar to our previous proposal. 3 principles were still needed. The first one, no extra labor or equipment should be added to the construction site. Second one, no idle time between the activities on the critical path. But the third principle is slightly different. We started trying to divide some of the activities that we originally thought cannot be divided. For example, installing the hooks. Based on proposal number 1, our proposal number 2 have divided the activities furtherly. Moreover, we assigned the labor and resources in a better way. Thus, we finally utilized the idle time of 2 workers from the proposal number 1 to make them help fix the panel to the ground. Eventually, proposal number 2 shortened the cycle time by 9 minutes, with an improved productivity and a lowered cost. And here comes to our proposal number 3, which is our final proposal and also at the same time the proposal in which we made the most changes. In this proposal number 3, we tried to ignore the limits of the site to some degree, just to explore the theoretical potential of the construction process. The biggest change we made is we added an extra crane and 2 extra laborers. At the same time, erecting, locating, and hook removing remained undivided. The new crew balance chart for the proposal number 3 could help you better understand our proposal. Because of the better available of resources, we managed to assemble 2 panels within the original cycle duration, 38 minutes. The productivity got boosted greatly to 0.316 slab per man-hour. But on the other hand, the cost for every slab assembling goes higher to $395.5 per slab. For the 3 proposals we produced, we also made 3 different implementation plans for them. These implementation plans show exactly how each proposal will be carried out. Now let's take the implementation plan for our first proposal as an example. According to this implementation plan, by the end of 5 minutes, all the support installation and hook installation should be finished. And by the time of 22 minutes, the panel should be carried by the crane to its specific location. And by the end of 31 minutes, the panel should be totally fixed to the ground and other works should be carried out. What's more, different implementation plan also shows the difference in strategy between different proposals. Different from the previous implementation plan, this implementation plan 2 has less time nodes, and the activities after 22 minutes are all combined together, which on the other hand shows a higher efficiency of the proposal number 2. The implementation plan 3 should be the most special one among all of the 3 different implementation plans, because our proposal 3 has a totally different strategy. Thanks to the extra resources we added, which means 1 extra crane and 2 extra laborers, the third proposal has a feature of double critical path. Such a feature is reflected perfectly in its implementation plan. After all these studies and analysis about the set condition, those 3 different proposals, and their implementation plans, it might be a time to draw a conclusion. The construction site has problems on both safety aspect and productivity aspect. Though part of the reasons come from the scale and the dimension limits of the construction site itself, improvements are still possible on both reality and theory. Based on different focuses and strategies, the result of the 3 different proposals are shown in the table. Eventually, there may not be a best option, but there always exists a most suitable option for different conditions. Above are all the contents of our presentation about the productivity improvement study. Thank you for your patience and time.